Okay, so we'll go through the blueprint reading basics. This is unit 10. We will go over the machine terms and the manufacturing processes. Okay, these are the learning objectives. Basically, it's going to be more of a terminology, so you need to know what a chamfer is, deburring, knurling, serration, key seat, keyway, a neck, an undercut, a groove, and a saw cut. So many of you already know these, we'll just review them. And then there's a symbol that we're going to cover. It's called the edge state symbol, what it means. And then interpret the notes for a key seat, a keyway, and machining centers. And then we're going to talk about manufacturing holes, and then terms like drill, ream, bore, and broaching. Okay. We'll talk about also milling and grinding. We'll go through the thing. So the first thing is the burring. Burr is left off material on the edge of the part. Usually they're very sharp to the point sometimes they're almost like a knife edge. It's a normal byproduct for all machining. And then a print may specify how to deal with burrs, like it would, or it might be left off to the standard machine shop practice, which is basically we deburr everything. So here is the edge state symbol, which is this one, and then it tells you for here we got two groups. This is an external edge, and here is an internal edge. So in case it's an external edge, it could give you a range. Then which means here is that the undercut or the chamfer or the radius that you're going to use should be between 10 thou and 20 thou. That's what it means. Here, it's giving you a specific number. It says an undercut, yes, so there's no bearing, an undercut up to 300 thou. That's pretty generous. Okay. Now, in the internal edge, you have two options. It's always on the plus side. So for an external edge, it's on the minus side. For an internal edge, it's on the plus side. Either you're getting a range. So here, for example, plus 300 thou or plus 600. Again, the radii, the chamfer you're going to use between this and this, 300 and 600, or it would specify a specific value. So that's the edge state symbol. Knurling is small V-shaped grooves. Basically, they're made to create friction. And to make rough surface, sometimes decoration. Rough surface creates friction and decoration. Some of them are diamond shaped, or actually the most common way is this one, the diamond knurling. But however, you can have a straight knurl, and then usually they're shown on the drawing as an area like this, and then it's usually labeled diamond knurling. Serration is a much deeper knurl, like the depths of the same shape is much larger, and then it's V-shaped groove, and then also generally diamond shaped, and then they're used to really reduce slippage. That's created to make a lot of friction. So next is key seats and keyways. So this is a key seat. It's a groove in a shaft, and a keyway is a groove in a hub of a flange, a gear, anything. And then they both go together. and their job is to transmit torque from the shaft to the gear or pulley or whatever you want to call it. So it's transmitting shaft. So when this is turning, the key that sits in here is pushing the gear. Okay? There are specific standards for the dimensions of the keyway and the key seat, and specific tolerances. The reason for it is you don't want it to break, because this is a make or break. That's basically what's keeping your car going, or whatever that's keeping your machine going. If that key breaks, fails, there is no power transmission. So it's highly specified and regulated for that reason. There's specific material for the keyway, and then there's specific geometry that's listed here. The same idea here's for the key seat. And now we're going to talk about some features. A neck allows flush sitting of the bolt onto the surface. Okay, that's the job of a neck. If you're having a radius, you can't have a flush mating. Then you're going to have this gap, which is going to be basically the amount of radius you have. A groove or an undercut, it's all the same thing. Okay, so here it's called an undercut, here it's called a neck. You can also call it a groove. It's all the same thing. So we'll leave you the review question for you to go through. Now let's go through more terminology. A saw cut is basically something being cut by a saw. A mill, which is using the milling machine. So, and then a grind means using the grinder. When we go to holes, you can drill a hole, which is using drill bits. Ream a hole, you achieve higher precision and use a reamer. Boring is the same way, you use a boring bar, which is the same way on a lathe. Counter bore is that shape. And then counter sink is that shape. Counter drilled is that shape. And then spot face is the same thing as a counter bore, but it's much smaller. Then we talked about threaded. Broached is basically not drilled, we use the press brake for it. Okay, so we create that hole using the press brake. Okay, so here's broach, we can use EDM, which is something that uses high voltage to melt out the material and drill through. And then, okay, the current practice, we do not specify the process, but sometimes it might be written down. Then the machining centers. Machining centers are required to mount the cylindrical part onto the lathe. It's a feature for you to mount the cylindrical part onto your lathe, especially with large shafts. Typically, when we mount something onto the lathe, this is the lathe chuck, we use one side, but then there is a limit how long that shaft has to be. If the shaft is too long, then I would use a machining center here to mount the part on 2 points, so it's very well supported. So these are the symbols. If you have that symbol, it means that you have to use a machining center. Here, he's giving you the option, up to you. You can use it or you cannot use it. But here, it means you're not required. You cannot put in a machining center. So what does a machining center look like? It looks like this. It has a standard shape. It's a groove that looks like this, and then a V-shaped part comes and sits in it, and this is what creates the support, the second supporting point. The machining center comes in different dimensions, and it's well standardized, whether the ISO or the ASME standard, and here's a table that summarizes the common dimensions for the machining center. Same stuff, here's the ASME standard. Okay, usually parts have marking on them, and then the drawing would specify what type markings you would have. Sometimes you have the item number in revision, a serial number, production lot, a company logo, or any other marking. You can do that by electrochemical etching, emboss, which is almost like stamping, but mechanical stamping, an ink stamp. You can use an inkjet printer, laser marking, laser etching, marking, painting, scribe. All of these are options for making markings onto your part. Your drawing might specifically say laser mark so and so onto your part, and it shows where it's supposed to be. So these are review questions. I think then we're done with this. The rest you can read. It's pretty self-explanatory.